Hello and good morning. This is the Vasis Mohanty. Today I will do the discussion of one of the theorem, and which theorem will help you to prove the Pythagoras theorem. Everyone, you just have to listen carefully. Today one of the important theorem it is to be that theorem which will help us to prove the Pythagoras theorem. Understood or not understood? Only see carefully. Everyone, you just have to see carefully. See, here it is one of the triangle I am showing. Here it is one of the triangles. See carefully. And the name of the triangle it is suppose A, this one it is B, and this one it is our C. See, from the picture I will say you everything what is the statement of this theorem. And this one it is right angle at B. From the figure, the right angle triangle and the right angle triangle vertex name it is your B. Suppose from the B, if I will draw another perpendicular to our hypotenuse AC, so it means this little triangle it is similar to this little triangle. Then after you just have to remember both the little triangles are also similar to our larger triangle. Actually, the statement of this theorem says in any of the right angle triangle, if I am drawing one of the perpendicular from its right angle B, otherwise from the right angle triangle ABC, from the right angle B, from the point B, if I am drawing any of the perpendicular to its hypotenuse, whatever the two little triangles we obtain, both the triangles are similar to one another. Along with both the triangles are similar to our larger triangle. Perfectly understood? See how we can prove this. It is very easy. Only in the picture we will complete everything. Only in the picture everything I will complete. See perfectly. Suppose the point it is our D. Everyone you have to see. Suppose the name of the point it is D. See carefully. In this right angle triangle, see, in this right angle triangle, this one it is 90, it means this one it is 90. Suppose this angle I am taking it as the X. As you know, this angle it is your 90 degree, so it means 100% this angle, their sum it is equal to 90 degree. In this particular triangle, as this angle it is 90, it means sum of these two angles it will be 90 degree. And this one it is X, it means this angle it will be 90 degree minus X. Perfectly understood? Understood perfectly. Then after, see, this angle B angle it is our 90 degree. B angle it is our 90 degree. Otherwise just wait. This B angle, see, this B angle it is our 90 degree. Whenever this one it is 90 minus X, so 100% this little angle, it will be our X. Otherwise, whenever I will add this angle with this angle, now their sum it will give us 90. Now see, this angle it is 90, this angle it is X in this triangle. 90, this one it is your X. So 100% this one it will be our 90 degree minus X. So it means whatever the angles we have obtained, all the measures of the angles we have already written. See one thing, the important thing I am showing. Everyone you just have to see. This triangle and this triangle you just have to see carefully. This triangle and this triangle means both the little triangles you just have to see carefully. Actually my intention is, anyhow I have to show that both the triangles are similar to one another. Understood or not understood? See, to be similar, as we have already got the measure of all the angles of this triangle and measure of all angles of this triangle, so for which if we can show that two of the angle measure of this triangle, if it will be same with the two of the angles measure of this triangle, by using the AA similarity criteria, we can say that both the triangles are similar. Otherwise, by using AAA similarity criteria, also we can show that both the triangles are similar. See, for which I am matching. See, just here x angle of this triangle, it is the same as the x angle of this triangle. First point perfectly understood. So it means first I am matching the angles of this triangle and angles of this triangle. Which one it is matching with which one? See, then after everyone see, then after this 90 degree, it is matching with this 90 degree. Understood? So it means only these two angle comparison, it is enough to prove that both the triangles are similar. But here namely I am showing, see, namely I am showing this one, it is also same as this one. So by using AAA similarity criteria, it may be. Otherwise, by using AA similarity criteria, it may be. Either AAA, otherwise by using AA similarity criteria, I can show, see everyone perfectly, I can show triangle ABD, see perfectly, triangle ABD, it is similar to, ABD means this triangle, A, it is matching with B, right side it is matching with B, because A angle it is how much, here it is B angle also that much. So here it is second one, it is B, so B means BX, so it will match with C, so for which BC, and here D matching with the D of this triangle, so for which triangle ABD it is matching with the triangle BCD. Actually we can say, otherwise anyone can say that both the triangles are similar, but the important one it is our which vertex matching with which one, that one it is the importance. Otherwise the order of writing the vertex, order of writing which one it is A, then after second it is B, second it is D, here it is first it is B, here it is C, then after this one it is D. So important one it is A is matching with B, here it is B is matching with C, and D it is matching with D. It bears the importance. Perfectly understood? Perfectly understood. Now I want to show you another thing. Just like previously I said, this little triangle similar to this little triangle. Now my comparison it will be on this little triangle with the larger triangle. See carefully. See, this little triangle once again I am drawing such that you will get more meaningful and more clarity you will get. See, this little figure I am drawing, suppose this little triangle. See, perfectly see. See perfectly, this little triangle I am drawing. Here it is A, this one it is our B, this one it is our D, and already we got this one it is our 90 degree minus X, this one it is our X. Already this triangle, all the angle measures already we obtained. Now I am drawing the larger triangle. See carefully. Larger triangle name it is our ABC. A, this one it is our B, this one it is our C. B angle larger one it is your 90 degree at B. See one thing, here it is X, and this one it is our 90 degree minus X. See now, from both the triangles, this X it is matching with this X, this 90 degree it is matching with this 90 degree. So no need to check for the third angle. Otherwise, if you are checking this one, it is automatically it is same as this one. So it means we have already got B will match with C, D will match with B, and A it will match with A. It means both the triangles are similar according to our AA similarity criteria, otherwise by AAA similarity criteria. So for which I can write, see, order it is important. I can write ABD triangle, ABD I am writing, it is similar to, see, here it is A it is 90 minus x, here it is 90 minus x. So for which this A, it will match with this A. B of this triangle, it is matching with C of this triangle. So for which B angle it is x, but in the larger triangle C angle it is of your x. Then after B it is matching with C. Then after D it will match with B. So for which D, here I am writing it as the B. Understood? So both the triangles are similar as per our A similarity criteria, otherwise as per our AAA similarity criteria. Okay? So so in the second case, so we did the comparison of the similarity of this little with the larger. Now I am showing that this little triangle with the larger triangle, how both the triangles are similar. See carefully. See carefully. Here it is BDC triangle I am drawing. Here it is B. This one it is our B. Then after this one it is our D. This one it is our C. See, this one it is our 90 degree little triangle. This angle measure it is our 90 degree. This one it is our 90 degree minus x. And this one it is our x. So it means this one it is our x. This x it is matching with this x. This 90 degree minus x it is matching with 90 degree minus x. So for which dot mark I have given for both the cases. Then after this 90 degree it is matching with this 90 degree, for which I get the cross mark for the B angle matching with the D angle. So now I can say, see, now I can say triangle BCD. See carefully, triangle BCD means BCD. Everyone see it carefully. B of this angle, this triangle, it is matching with, B is matching with A. 90 minus x, here it is 90 minus x. B is matching with A. Then after C will match with your C. Here C, also here it is also C. And D will match with your B. D, it will match with your B. So it means it is clear from both the figure. B, it will match with A. C, it will match with C. And D, it will match with B. One can write it as the according to our A similarity criteria. Otherwise, one can call it as per our AAA similarity criteria. Both the triangles are similar. Perfectly understood? Actually, whatever the thing I have already proved the similarity criteria of the three angles in the three cases. Listen, all are also one question. It means this one it is similar to this one, it is one question. This little it is similar to the larger triangle, it is another question. And this little it is similar to this larger triangle, it is also another question. It means perpendicular drawn from the right angle, from one of the right angle of a right angle triangle, perpendicular drawn from a right angle of a right angle triangle to its hypotenuse. It divides the two little triangles. The two little triangles are similar to each other. Also the two similar triangles are similar to the larger triangle. Understood? Perfectly understood. And also each one is your one question. Also each one it is your one question. Understood? Same criteria it will be given, but only it may be asked that you have to prove that this one it is similar to this one. You can prove just like this. One may ask to you, this one it is similar to the larger one. Also it may be asked to you. Also it may be asked that this little triangle it may be similar to the larger triangle. It may be first case, it may be second case, it may be third case. Always you have to prove it by using whatever the formula I have already said to you. Accordingly you have to solve. Understood? Everywhere A similarity criteria, otherwise A similarity criteria you just have to apply. Okay, so next I will show to you how you have to prove the Pythagoras theorem. Listen, shortcutly I am saying. Actually in my class specialty is everything I will do the discussion by the pictorial form. It means statement I will say you by showing you the figure. Many of the things I will say you by showing the figure. Very less things I will write. Very least thing I will write on the board. Understood or not understood? See, actually this much thing it is already over for the one of the theorem. See, then after I will show to you, picture it is same. See, picture it is same. Everyone you just have to see. Picture it is same. Picture it is same. But here it will be asked to you, listen, actually Pythagoras theorem says, everyone you just have to remember, actually Pythagoras theorem says h square equal to p square plus b square. This one it is the Pythagoras theorem. We will prove this one, but here how I will show to you, how I will say you the statement, also how you will get the question in the exam regarding to your Pythagoras theorem. You just have to prove the Pythagoras theorem. It may be asked, otherwise it may be asked that in a right angle triangle, you just have to prove the square of the hypotenuse means AC. You just have to show in a right angle triangle the square of the hypotenuse. See attentively, okay? You just have to prove in a right angle triangle, the square of the hypotenuse. Otherwise it is also statement. Remember, the square of the hypotenuse it is equal to square of hypotenuse is equal to sum of whom? Sum of the square of the other two sides. Sum of the square of the other two sides, it means AB square and BC square. Actually in the triangle three sides, one it is this one, another one it is this one, and the last one it is this one. So for which the square of the hypotenuse is equal to sum of the square of the other two sides. Perfectly good. Actually this one it is to be proved. Everyone see it attentively. This one it is to be proved, and the statement of the Pythagoras theorem, it is the square of the hypotenuse of a right angle triangle. It is the sum of the square of the other two sides. What I said, this one it is your statement. Perfectly understood? So it means everyone you just have to see this question we will solve by attempting from the right side. First we will get the AB square. Then after we will get the BC square. Then after we will see whether their sum it gives our AC square or not. Whether the sum it gives us the AC square or not. See everyone, perfectly you just have to see. Actually I want AB square. See how one can get the AB square in this chapter. See, AB by something, whenever it will be something divided by AB, then after one can say that AB square it gives us how much? Understood perfectly? Actually AB square one will get whenever AB by something equal to something divided by AB. Whenever the two ratios are in such a way, numerator AB also denominator also it will be our AB. So it means, see, numerator it is one of the, here it is the two sides of one triangle, and this one it is the side of the another triangle. Remember the trick. Actually this one it is the trick how to find out the AB square. It means you should have to choose the triangle in such a way such that the upper triangle also having AB, also below triangle also having AB. Important point, understood? Upper one having AB, also below one also having the AB. Which upper one? Which triangle we will consider that triangle having the AB as the two vertex, and below one triangle also having the AB as its two vertex, and upper triangle it is similar to the lower triangle. Two similar triangles we have to choose in such a way such that the both the triangles having two vertex AB it has the common. See here I am showing. Perfectly you just have to see. Here we have already got that the similarity criteria of the two triangles. Here already we got the similarity criteria for the three cases. So in the first case we got, everyone see it carefully. In the first case we got this triangle similar to this triangle. It is one case. Another one it is our this one. It is similar to the larger one. And next one it is this one. It is similar to the this one. See one of the trick I am showing. See AB square, one will get AB square. See this little triangle having one of the side AB. Also the larger triangle also having the side one of the AB. Otherwise from here also you can find, see AB, how one can find out the AB. Everyone see it perfectly. See, it means here it is AB and here it is AB. Understood perfectly? First understood perfectly. Then also at a time I am showing you how to find out BC square. BC square means, see from the figure, this triangle having the BC. Actually AB square and BC square we have to obtain. There are some we need to check whether it gives us the AB square or not. BC square one can find out. BC square means this little triangle having BC, also the larger triangle also having the BC. See also from the expression, see this one also having the BC, also this one also having the BC. So it means we can find out the AB square from the second similarity. It means we can find out the AB square from this similarity, and we can find out the BC square from this similarity. Understood or not understood? So for this, from here I am showing you something. As both the triangles are similar, 100% its corresponding sides are in the same ratio. So for which AB I got here, first and second AB. So AB divided by AC is equal to, thereafter I want AB, right side AB means first and third. So for which here also I will take it as the first and third. AD divided by AB. Also one can write it is also same as the BD by CB. But this one it is not required by us. This one it will not be useful for us. For which we will not consider that case. Perfectly got or not? Just like we got the AB square from these two sides. See, here it is AB, here it is AB. So it means it will give us AB into AB. It is equal to AB square is equal to AC into AD. So it means we have already got the AB square. Then after second target it will be our BC square. How to find out the BC square? See, I have already shown to you BC square you can find out from this little triangle and this larger triangle. Otherwise from here I have already got, see how to find out the BC square. See, here it is first and second. It means first, second, and the three sides are first and second, second and third, and first and last. But here it is first and second having BC, and here it is second and third. So for which only we have to choose the ratio of the side of the first, second, BC divided by AC. Then after right side having the second and third having CB. So for which here also we will choose it as the second and third. So for which it will be our CD divided by CB, which gives us, see perfectly, BC, here it is BC, it means our BC square is equal to AC into CD. So here we have already got what will be the value of our BC square. Here we got AB square and here we got it as the BC square. So finally we will see that the right side AB square and BC square togetherly will give us AC square or not. So it means now we are starting from our RHS. See, actually our RHS gives us AB square, see perfectly, AB square plus a BC square, and in place of AB square I got it as AC into AD. AB square means AC into AD, and here it is BC square I got it as AC into CD. From both the term, AC it is common here, AC it is also common, it is at here. So for which we can take AC it is the common. By taking AC as the common, the non-common one it is our AD and CD. AD into CD. See, finally we will get, here it is AC, I will write it as the AC. And here it is AD into CD, AD plus CD, sorry, AD plus CD. See, AD plus CD, so it will be our AC. So for which AC into AC, which gives us our AC square. AC square means I started from right side and I got it as the LHS side. So for which I got it as the AB square plus BC square, it is equal to AC square. Understood how we got the value of AB square and BC square? Actually, how I have planned to find out AB square. By the similarity of the two triangles where AB it is common and BC square, I have to choose the two triangles where BC it is the common. So this plan, it will be useful for us to solve the next question from our coming exercise. Today you have to remember all these things. So in our coming days, we will apply on these all things to solve the question. Okay, thank you. Have a nice day.